Bismillahirrahmanirrahim. In the name of God. How are you, everybody? Today we will take a revision about important part in your curriculum, which is induction. We studied up till now Faraday's law, the induction. Then we studied Faraday's law, motion of wire inside magnetic field, mutual induction between two coils, and the self-induction. The laws which we studied, laws which we will study up till now: induced electromotive force EMF equal minus N delta phi M over delta T. For wire, EMF equal B LV sin theta. For natural coils, EMF equal minus N delta phi M over delta T equal minus M delta I over delta T. Self-induction for a coil determined by induced electromotive force minus N delta phi M over delta T equal minus L delta I over delta T. And we know that the factor of self-induction equal mu N power 2 A over L. Also, we know the unit of measuring of factor self-induction or factor mutual induction is Henry unit of measuring, which equivalent ohm second or volt second over ampere, or another unit which we explained before. Today we explain important idea about induction. This idea you must know that. You must know this idea. What idea we will study? We have a problem, page 129, number 10. This is problem contain good idea. Good ideas, you must study this idea. In this problem, we give a relationship or graph between torque and time. This point called A and this point called B. The opposite figure represents a graphical relationship between the torque acting on rectangular coil of N turns. بيقول لك الشكل المقابل بيعبر عن العلاقة بين التورك والايه with theta. Okay? Acting on rectangular coil of n turns, cross-sectional area which rotating a uniform magnetic field flux density B and the angle theta between the normal up to the plane of the coil and the magnetic flux line. Number E, find the torque, the values of theta and tau at point E. Look at this point. This point expresses what? This expresses maximum torque. Torque we studied in chapter 2 determined by the mathematical relationship NABI sine an angle. N the number of turns of the coil, A is the area, B is the density of the magnetic density, I is the electric current intensity, theta is the angle. Okay. At this point, angle theta equal what? Angle theta equal 90. So, theta at this point equal 90. And sine theta, sine this angle equal 1. So the torque equal NABI sine 90. So this value expressed NABI. This is maximum torque. Maximum torque. Okay. And at point B. At point B, theta equal 180. Okay. So sine theta at point B equal 0. So the torque equal also 0 because torque equal NABI sine 180 equal 0. Okay. We complete this problem. We have a part in this problem for high level, but it is easy. He gives you this graph between density, magnetic density, and time. The lower part between EMF and time. This point of 0 for the relation between B and T. This point is 0 between the relation between induced electromotive force and time. Okay. He gives what? He gives this graph for density, magnetic density. This part. And he asked me about graph between induced EMF and time from this graph between B and time. Look, we explain that EMF equal minus M delta phi M over delta T, where M is the number of turns of the coil. Phi is magnetic flux. Delta expresses what? Delta is important. It expresses the rate of change. To make electromotive force, you must have rate of change. Okay, we have phi equal BA sine theta. So this rate of change may be a change in magnetic density, or a change in area, or a change in the angle. Okay? This relation, not a change between B and T. Oh, how can I draw a graph between induced EMF and time? You must make rate of change of density B. Okay, look at this point. 0, A, B, C, D. From point 0 to A, the magnetic density constant. Okay, that's mean what? That's mean the rate of change of magnetic density equals 0. How, mister? If this point equal 5, okay, the rate of change from 0 to A equal 5 minus 5. That's mean what? Rate of change equals 0. We can draw this point from 0 to A. This is the relationship of electromotive force. Okay. At point A, you are very hungry. You are very hungry, constant. So the rate of change for eating must be higher. Okay. The rate of change at this point, we can find it by the slope. The slope at this point is large positive, and the positive decreases. The positive decreases. At this point, the slope equals 0 again. At this point, the slope is maximum. So, maximum in positive sign. Again, to understand this point is important. The slope at this point is positive. It is large positive. Okay. So the induced electromotive force formed in the opposite direction. If this direction is positive, EMF in negative direction. So EMF is maximum in negative region. In negative region. Okay. This is OA. And what? At point B. Look at point B. The slope here equals 0 because rate of change of magnetic density equals 0. So electromotive force becomes 0 at point B. At point B, electromotive force equals 0. So from A to B, this value and return to 0. Okay. From points B to C, we have negative slope, and this negative increases. Okay. From point B to C, at this region for magnetic flux become negative, so electromotive force become positive. Understand? So we can write this line in positive region to express induced EMF. This is the relationship between what? Between electromotive force and time. أما يديني when he give the graph between density and time. Because we express induced electromotive force by rate of exchange. You must know rate of exchange, rate of exchange, rate of exchange. This exchange may be in magnetic density, may be in area, may be in the angle. Okay, this is good idea and problem. We will explain another idea. This idea page 141, number 5.